In this lecture, we solve the differential equation in bracket x square y square plus xy plus 1 whole times of y dx plus inside the bracket x square y square minus xy plus 1 whole multiplied by x dy equal to 0. So consider the differential equation x square y square plus xy plus 1 whole multiplied by y into dx plus x square y square minus xy plus 1 whole multiplied by x into dy equal to 0. Let us give it equation number 1. Comparing equation 1 with the standard differential equation m dx plus n dy equal to 0, we get m is equal to x square y square plus xy plus 1 whole times of y and n equal to x square y square minus xy plus 1 whole times of x. So let us multiply this term or open this bracket. So if you multiply by y, so this will become y cube. So x square y cube plus xy square and plus y. Xy square plus y. Similarly here, x into x square is x cube y square minus x square y plus x. So this is the value of m and n. Let us check that the given differential equation is exact or not. So for checking this purpose, we have to check that what is the derivative of m, partial derivative of m with respect to y and partial derivative of n with respect to x, both should be same or not. So what is the partial derivative of m with respect to y? So what is the x square is constant, derivative of y cube is equal to 3 x square y square plus 2xy plus derivative of 1 is y is 1. So this is del m del y, partial derivative of m with respect to y. Similarly, the derivative of x cube with respect to x is 3x square y square minus 2xy plus derivative of x is equal to 1. So if you see that all the terms are similar, but here this is minus sign and it is plus sign. So clearly del m del y is not equal to del n del x. What it means? It means that the given differential equation is not exact differential equation. But this differential equation has the form y times of f of xy, f1 of xy into dx plus x into f2 of xy dy equal to 0. So its integrating factor is given by integrating factor is equal to 1 upon mx minus ny, where m is equal to x square y square plus xy plus 1 whole times of y and n equal to x square y square minus xy plus 1 into x. So let us multiply over here. Again, we have to multiply this m by x, this m by x, and this n by y. So we have x square y square plus xy plus 1 into yx minus x square y square minus xy plus 1 into again this should be multiplied by y. So it will become x into y, xy. Now let us open the bracket. So x square y square into xy is x to, okay. What we can do, xy is common in both the term, we have to take outside. So x square plus xy plus 1 minus x square y square plus xy minus 1. So x square y square positive, x square y square negative, plus 1 minus 1, both will cancel. So we have xy in plus xy is 2xy, which is multiplied by with xy. So 1 upon 2 x square y square. So this is the integrating factor. So in integrating factor, sometime we can also write down integrating factor is 1 upon x square y square, or we can also write down integrating factor is 1 upon 2 x square y square. So both any one is true for integrating factor of the given equation. Now Let us multiply this integrating factor to the given differential equation. So as per the rule, if you multiply any differential equation to its integrating factor, that should be converted to exact differential equation. So let us take it. Multiplying equation 1, which is x square y square plus xy plus 1 whole times of y dx plus x square y square minus xy plus 1 whole times of x dy equal to 0, by its integrating factor 1 upon 2 x square y square, we get x square y square plus xy plus 1 upon 2x square y square into y dx plus x square y square minus xy plus 1 upon x square y square x dy. So one y will be cancelled over here, this y will cancel, and one x is cancelled over here. So x square y square upon, so x square will cancel and one y will be cancelled. So we have y upon 2 is the first term. Similarly, in the second term, x will cancel, y will cancel, then it is 1 upon 2x. Plus, if we take the last point, 1 upon 2x square y whole dx plus, now here x square will cancel. No, this x will cancel. So one x is cancelled, one x is remaining over here, y square will cancel. So x upon 2, that the 2 is missing over here, this is 2, x upon 2 minus two, let me just clear it. One x is cancelled, so x will again cancel, y will be cancelled also. So minus 1 upon 2y, there is a 2 over here, and plus 1 upon 2xy square dy equal to 0. Now comparing this equation number 1 with the standard differential equation m dx plus n dy equal to 0, what is the value of m? M is equal to y by 2 plus 1 upon 2x plus 1 upon 2x square y, and similarly n equal to x by 2 minus 1 upon 2y plus 1 upon 2xy square. So now just look here. If you multiply whole equation by 1 upon 2, multiply whole equation by 2. So the integrating factor can be also taken as 1 upon x square y square. It can be also worked. Now, so m equal to this, n equal to this. So m is equal to y by 2 plus 1 upon 2x plus 1 upon 2x square y. Similarly, n equal to x by 2 minus 1 upon 2y plus 1 upon 2xy square. Let us find out what is the value of del m del y. So del m del y equal to, this is 1 upon 2. This is 0 because it is free from y. And it is 1 upon derivative of 1 upon y is minus 1 upon y square. So 1 minus 1 upon 2x square y square. Similarly, partial derivative of n with respect to x is derivative of x is, this is x by 2 is 1 by 2. And derivative of this will be 0 because it is free from x. Again, derivative of 1 upon x is minus 1 upon 2x square y square. So clearly equation 2 is exact differential equation. Hence, equation number 2 is exact differential equation. So let us try to, therefore, the general solution of the given differential equation 1 upon y, or y by 2 plus 1 upon 2x plus 1 upon 2x square y into dx plus x by 2 minus 1 upon 2y plus 1 upon 2xy square whole multiplied by dy equal to 0 is given by integration of m with when y is constant with respect to x plus integration of terms of n free from x whole dy with respect to y, which is equal to c. So m is, this term is m. So integration of y by 2 plus 1 upon 2x plus 1 upon 2x square y is constant over here, plus the term free from x is only one term, which is minus 1 upon 2y in the second term. So integration of minus 1 upon 2y with respect to y equal to c. Now, y by 2 we can take outside because y is constant and 2 is also constant. So integration of dx plus 1 upon 2 we can take outside. Integration of 1 upon x dx plus 1 upon 2y can be taken outside. Integration of dx upon x square minus 1 upon 2 we can take outside. Integration of dy 1 upon y with respect to y equal to c. Now we know that what is the integration of dx? It is x. Integration of 1 upon x is log x. And integration of 1 upon x square is minus 1 upon x. Let me show you how it will be x to the power minus 2 dx, which is equal to x to the power minus 2 plus 1 upon minus 2 plus 1, which is x to the power minus 1 upon minus 1, or we can write down minus 1 upon x. And again, integration of 1 upon y with respect to y is log of y, which is equal to c. If we simplify it, it is x by 2. It is 1 upon 2 log x. Or we have to first multiply whole equation by 2. Then it is xy log x minus 1 upon xy. This is minus x 1 upon xy minus log y, which is equal to 2c. And it can be written as x square whole multiply whole equation by xy. So x square y square into xy log x minus 1 minus xy log y, which is equal to c1 xy, or x square y square minus 1 plus xy log x minus xy log y equal to c1 xy. So therefore, x square y square minus 1, and we can write down, we can take xy outside. So log x minus log y is nothing but log of x by y, which is equal to c1 of xy. And this is the desired general solution of the given differential equation. Thank you.